Alright, here's a polynomial intro. This topic's kind of fun. It's not nearly as bad as some of the things we've been doing. So these first three questions here wouldn't be a bad idea for you to try to do them on your own just to see if you could discover rather than just listening to what they are. So if you wanted to press pause and take a look at these first three questions and see if you could figure it out, that would be a good thing, but most people don't do that, and that's alright. So what you see in these equations up here, these graphs, is the equation's been typed, and this is what the graph looks like. And I typed the first one just so you can see that on a traditional graphing calculator it doesn't all fit, and that the y values have been manipulated. So if you wanted to see that I've typed that equation in there and then go to the window and manipulate the window so that you could see it looks like the y values have been stretched. So if I change that to negative 60 and the y max to positive 60, we should be able to see this guy a lot better. Now, here's what the first three questions are trying to get you to discover if you didn't want to try to do it on your own. It says, what are the x-intercepts and how are they related to the equation? You'll notice this x-intercept here is positive 2 and the other one is negative 5. And you'll notice where positive 2 probably came from and where negative 5 probably came from. And remember, when you're finding x-intercepts, the y value is 0, so if you were to put a 0 here, basically, it's like finding the x-intercepts of a parabola or a quadratic, where we just know, oh, that guy is 2, and that guy is negative 5, and that's basically what it is. Okay, so finding the x-intercepts is going to come from what x values make the problem equal to 0. Now, question 2 here says, what exponent of 2 did that affect on the x-intercept? So this 2 here, the question is, how did it affect the x-intercept? And the answer is it didn't. Negative 5 was still an x-intercept. Are there any other squares? This one over here on the third graph, x minus 2, which means the x value 2, which is right there. That's still an x-intercept, but you may notice something that's happening on the graph at that moment. What's happening here at negative 5 that didn't happen here? And what's happening at positive 2 on this third graph that maybe didn't happen here or happen here? And if you discover that on your own, it's kind of cool to kind of make a conjecture and see if you're right. How does the exponent of 3 affect a graph? If you know the only x-intercept that's 3 is way down here at the x plus 1 cubed to the third power. So if we go to the x plus 1, which would be the negative 1, maybe you can't tell, but there's a cute little bend happening right there. And this is supposed to kind of look like a cubic graph. And that little cubic bend that you see right there happens because of that 3. So, what did the squared happen? What was happening at the squared here and here? And what you're supposed to see and start to recognize is, oh, that's forming a parabola. It's forming a parabola. This one happens to be upside down. It could be right side up, which I'll show you here in a second. But it's forming a parabola where the squareds, the x minus 2, that exponent right there is a 1. We just don't write it. And you'll notice what's happening there. Well, the graph's just going straight through it. Look at all of these on this middle one. They're all going straight through the x-intercept. Nothing happening. There's no parabola being formed. There's no cubic being formed. So when it goes straight through, the exponent is a 1. So those are the three things we're going to do in this class. It's either going to be a 1 or a 2 or a 3. And those are the three different shapes that happen at that x-intercept, which is kind of cool. So if we go down to 4a now and we try to use some of those ideas to write an equation, we can do that. The first one here is kind of tough because the x-intercept, that's a 3 and that's a 4, and unfortunately they're kind of close together, which makes this tough to see. But if I were to start to write an equation, and I always just go left to right here when I'm just writing my equation, but it doesn't matter the order because it's all multiplication. This is going straight through negative 2, which means the binomial x plus 2 has to be in your answer. The exponent here is either going to be a 1, a 2, or a 3, and since the graph's going straight through, it's a 1. And since it's a 1, I'm not going to write anything. So then the graph continues and it heads over here and it hits at positive 3. Because it hits at positive 3, the binomial we need is x minus 3. And since the graph's going straight through it, even though you can barely kind of tell, the exponent is a 1. And then it turns and it heads back up and it crosses there at positive 4. And because it crosses at positive 4, we need x minus 4. And that is that graph. That's that equation right there. That's all we need to do. Use your previous answers to help you write equations. Reasonable. It says reasonable equations, and I'll get into that on the next topic, but we don't have to worry about why the word reasonable is there today. So let's head to B. So I have the graph crossing at the x value negative 1, which means it needs to have the binomial x plus 1. And then I need to ask myself, is it going straight through? Did it bounce off to form a parabola? Or did it have a funny little cubic curve running through it? And since this one's going straight through it, the exponent there is a 1. Then it turns and comes back up and it heads through positive 1. And since it heads through positive 1, I need the binomial x minus 1. And since it's going straight through it, the exponent there is a 1. And now we have one more to do. Looks like that guy hits right there at positive 3, and since it hits at positive 3, I need the binomial x minus 3. And this is the first time where we see the graph forms a parabola. Now I'm going to hear, you can hear me say that it bounces off. When this bounces off the x-axis, and that's what forms a parabola, bounces off the x-axis, then it came from a squared. The top examples, it bounced off underneath. It does not matter if it bounces off going up or bounces off coming underneath. You just need to know the difference between, is it going straight through the x-axis, like the first two here, or did it bounce off? And bounce off means it came from a squared. So if we look at C, C is great because it has all three types here. So let's see where I can write this. Y equals... Here is a negative 1, so I'm going to write the binomial x plus 1, and I see that it bounced off of it. So as I'm tracing and it bounces off means it was squared. And then I head up and I head down, and the next x-intercept I'm going to have is positive 2, and since it's positive 2, I write x minus 2. And now I have to ask myself, what shape is this? And hopefully you can see this is that cubic band, a little cubic curve to it. So that means the binomial had to have a 3, cubic band. And then it passes through and then it comes back down and heads up to 4, which means I need to have the binomial x minus 4. And then ask myself, does it bounce off? Does it do a cubic bend? Or does it just go straight through? And if it goes straight through, then it's just a 1, so I don't need to write anything. Alright. I'm going to leave D for you to try. You can check the answer key if you want to check that. I'm going to do another video and do the backside, or the page 2 of this ditto.